Good morning to all. Welcome to ImageGrafix webinar. Today's topic is 3D modeling and detailing by SEG Software. So this will going to help you for your pressure vessel, storage tank, heat exchanger design. So detailing of that drawing will going to give you a good confidence, and this software will going to help you a lot. So today we have a presenter. My name is Fauzan. I take care for all the analysis solutions. Along with me, I have Mr. Ahmed Hegazi, who will be going to present today. He is a developer of the SEG software, so he will be conducting the session. So regarding Ahmed, he is basically a mechanical engineer by profession. He's having more than 13 years of experience in the oil and gas industry. So he is into designing of the pressure vessels, storage tanks, and heat exchangers. He's having the strong knowledge on the ASME and API codes, and he is also an Autodesk Inventor certified professional. Okay, so he will be taking care of the session today. So just before moving on to the session, I would like to highlight about ImageGrafix. Okay, so ImageGrafix is founded in 1996, headquartered in the Dubai. Okay, and we have a group of companies which is into the, we have a engineering services division, we have software solutions, we have enterprise solutions. So we have different group of companies over here, and we have number of employees, we have 120 plus and growing. And this is the website www.image-graphics.com. So you will find lots of technical contents and all the blogs and newsletters on our website, and the latest webinar details also you will be able to find it on our website. So we have a few of the locations in India. Our headquarter office is in Chennai, and then we have some branch offices in Delhi, Mumbai. Then we have an office in UAE, okay, which is in Dubai and Abu Dhabi. So this was all about a small introduction about the ImageGrafix. I'll just hand over the session to Mr. Ahmed, who will be taking from now. Okay, Ahmed, over to you.
Okay. Thanks, Fauzan, for your presentation. This is Ahmed Hegazi, SEG owner. Today, inshallah, we will present one of the most important 3D modeling and detailing software for static equipment in the world. It's a static equipment generator software. So let's know more about SEG. At the beginning, let's ask, what is SEG software? It's an engineering application software. It's a design automation tool and a productivity tool for modeling and drafting work. By using SEG software, you can generate the 3D digital prototype, and you can generate the 2D drawings for your equipment. Before manufacturing, you can test your equipment, even if it was a pressure vessel, tower, storage tank, slug catcher, and other. Before the process of manufacturing and creating the fabrication drawings to detect if there is a problem like clashes or something like that before start on the second step. You can generate the bill of material for all of your project easily by using SEG software. By using this software, you can save up 80% from your time and money. Is that right? Is that real? Yes, it's real. Here, we make a comparison for a real project of a pressure vessel. This pressure vessel, we made it with different options. We create those drawings using the 2D AutoCAD software, and it's consumed around 50 hours to generate the GA drawings and detailed drawings, bill of material for this equipment. And by using a CAD software like CAD Works, Autodesk Inventor, CATIA, Pro Engineer, any other software, it takes around 35 hours to generate the 3D model and 2D fabrication drawings. But in case of using SEG software plus CAD software like Autodesk Inventor, we generate it in 8 hours, only 8 hours. all of those drawings and bill of material. So you can imagine how you can save a time. You can compare between 8 hours and 50 hours by using AutoCAD the traditional way. So you can compare that with a large scale in larger projects. So you can imagine how you can save from time and money by using SEG software. By using SEG software, you can generate many types of equipments under one umbrella. You can generate horizontal, vertical, and sloped pressure vessels by using SEG. You can generate the same for heat exchangers. You can generate storage tanks with a fixed roof. You can generate larger towers and columns with a multi-sectional sections and different diameters. You can generate slug catchers and piping. No existing software in the world make all of those equipments under one umbrella and one module. Those are some samples for real projects by SEG software. Here, as you can figure, is a storage tank with fixed roof, and you can figure the arrangement of plates, the roof arrangement and bottom arrangement, annular plates, spiral stairs, manway, and anchor chairs. Here for pressure vessels, small pressure vessels like air receivers, and complicated pressure vessels. And you can figure that you can make a complicated configuration like this one with valves and piping, and special shapes like enclosures. You can do all of that easily by using SEG software. The same for heat exchangers. You can make many types of heat exchangers by using SEG software, and you can, all of us know how it's complicated to make a heat exchanger, but by using SEG, it's too easy to do that. In SEG, you will deal with different levels. The first level is a project level. In this level, you will define some fields like the project name, client name, the owner, the location, manufacturer. All of that will appear on your drawing after creation of the drawing. The second level is the equipment level. In this level, you will define the design data of the equipment, like the construction code, design pressure, design temperature, corrosion allowance, wind, and seismic. And you have the ability to add more design conditions, and you have the ability to move or to remove or edit the current data. One more thing regarding to the vessel, which is the vessel setting. In the vessel setting, you can define the position of the vessel. You can make it you can make your vessel as a horizontal, vertical, or sloped. You can change the arrangement of the assembly. If you wanted to make it start from left to right, right to left, top to bottom, bottom to top. You can select your units. You can make it in millimeter or inches. And you can change the delivered blade dimensions. And this one is most important factor for the calculating of the circumference of the shell, because SEG will detect automatically if the delivered blade dimensions will cover the circumference length of the shell or not. Here for the storage tanks module, you can generate radial roof, arranged blade roof, dome roofs, bottom plates, sloped inside or outside, and flat bottom. You can create annular plates, and you can generate spiral stairs, clean outdoors, and manuals. And there is a special tool for roof and bottom plate arrangement. Here in this sample, we will create a project for a roof with 42 meters. And from here, we will select the project location. And we will add a new, define the delivered blade dimensions in this field, and the arrangement or the setting or position of the equipment. And from here, we will add a roof. And we will define the top inside diameter, the slope and thickness of the roof, define the bottom diameter of the roof. And from here, we will use the initial condition to start the blade arrangement. You can add a mid-row as an initial condition. You can make all blades center. So those are there are a lot of options to start your plate arrangement. You can flip the blade and make it vertical like this, and merge rows or merge plates. And from here, you will define the width of each plate like this. So you have a lot of options. You can make it to make it suits your requirements. After that, you will define the orientation of the first welding line at the top. After that, we will save the information of the arrangement. Okay, here we can make the plate on the left side, right side. After saving, we will start creating the model on Autodesk Inventor. You can figure that all data shall be created automatically. The assembly will started automatically. Right here, you can figure that all plates are assembled in one time. Okay, and in the bill of material, you can figure that all bill of material for this roof with the definition of each plate and the weight of each plate will appear on your bill of material automatically. The nesting tool. The nesting tool in Autodesk, it's a very important tool. You can use it to make a nesting for all plates in your project. So you can imagine how you can save from your time and money when you will use a tool like this. If you have different projects and certain plates, you can make a nesting for all plates of your project to get the required number or the actual required number for plates. Here we have an example. For this tank, we will make a nesting for the annular plates. We will open the assembly of the annular plates, and by using the nesting tool, we will send those items to the nesting tool. And from here, this nesting tool will detect the material for each element and the thickness for each element. And automatically, it will detect if there is any difference. So it will separate them, or they are identical in material and thickness. So they will be in one plate. Here we will define the delivered plate dimensions and start the nesting study. Automatically, the nesting study will not take a minute. After that, you will get a nesting for this. We have 12 elements, and we will need 3 sheet plates like this. And you can see the efficiency of using the sheet plates. We will do the same for the bottom. We will open the sheet metal flat pattern for the bottom, and we will make a nesting for the bottom by using the same tool. We will select the assembly, and from the drop down list, we will select create nesting. Okay, now in this stage, the nesting tool will detect the material and thickness for each plate to decide if it will be the same plate or it will be separate, if it's have a different material or a different thickness. Now we will start the nesting study. Okay, from here, after defining the delivered plate dimensions, now we have 18 plates, and we need 12 sheet plates to make to create the nesting for this, and the efficiency of this process is appearing. And you can generate a report, include all of those information for all items, and sketch for each nesting plate. So we'll save this nesting, and from here, that's the nesting report. Okay, now those are the elements right here. Okay, regarding to the heat exchangers, there is an integration tool in SEG Software. This integration tool deals with the exported CSV file from HTRI. So by importing this file, you can get all information about the tube sheet rolling. So it's automatically converted to SEG, and you can generate the tube pattern and tie rod, ceiling rod, sliding bars, baffles automatically by using this tool. So what is happen if you haven't an HTRI file, or you have an old equipment you wanted to make current hole pattern? We have a tool in SEG. By using this tool, you can make your own hole pattern. So you can select the tube pattern layout and select the position of the tube pattern select the number of pass partitions, and by using this tool, you can generate the tube pattern and tie rod pattern. In this small video, here we will define the inside diameter of the heat exchanger, the thickness, the tube clearance, tube diameter, and tube OD. And from here, we will select the pass partition number and shape. And from holes, we will make all holes in the right and left side are symmetric, and the same for top and bottom. Select the tube holing pattern and the big point if you wanted to make a big point to the center of the vessel. And from here, we will click draw. Now you have the pass partition. If we go to the tube passes, you can figure that the number of the tube passes is different in each room. So you can move the pass partition up and down, and you can figure here, after moving the pass partition, the number of tubes in each room become near 174 and the other 194. Now you can convert a tube to ceiling rod or tie rod. And by selecting the symmetrical, vertical, and horizontal option, if you select any tube, it will be automatically selected on the 4 quarters, like this. Okay, another more important option in SEG software, which is automated bill of material. You can get an automated bill of material by using SEG software, and you can export this bill of material in Excel format, and you can make a material cost report for your equipment by defining the cost of the material per ton, and you can export this report in HTML format. Another tool in SEG, which is nozzle opening. By using this tool, you can create all nozzle opening in your equipment, so you can make a clearance between the nozzle and the nozzle cap. If you wanted to make them all equal, you can do that. And if you wanted to specify a clearance for each nozzle separately, you have the ability to use that. Another tool in SEG, which is the sheet metal flat pattern. In this tool, you can convert all sheet plates to a sheet metal flat pattern, and you have the ability to export it in DWG and the DXF format. You have the ability to export the 3D model and the 2D drawings in many different extensions. You can convert it to AutoCAD DWG or Step IDIS SAT. You can convert it to CATIA part or CATIA product, many different extensions. Now we will talk about the drawings. You have the ability to generate the general arrangement drawing. You have the ability to generate a sub-assembly drawing. You have the ability to make a detailed drawing. In each drawing of those, you have the ability to add a lot of tables, like bill of material table, design data. You have the ability to add nodes, flange table. All of those tables shall be created automatically. You just select it and say, I wanted to make it appear in my drawing. For example, let's talk about the nozzle table. In the nozzle table, it includes around 21 fields, like the tag of the vessel, the surface of the vessel, size, outside diameter, thickness, pipe schedule, inside and internal projection, external projection, and more information regarding to the welding and attachment. Sorry. Here on the drawing, you have the ability to select the template drawing, which you will use it to start your project. So it's easy to select your template drawing and add it to the library of SEG. You have a rich library for welding details. From this library, you will select the standard welding detail that you wanted to make it appear on your drawing. Here, we will talk about the integration tool in SEG with BVLet. Here we have the 3D model or the design model on BVLet. So we will export the Access database file for this model from the BVLet. After that, we will import this Access file to the SEG software. And we will get the 3D model of this equipment on the CAD software. After that, by using SEG, we will generate this, the detailed drawings, the general arrangement of the vessel and bill of material. Okay, someone can ask me, so what is the difference between SEG integration tool with BVLit and the BVLit Inventor plugin? So let's discuss this. What about the features inside Elements? In SEG software, SEG can generate a detailed tree for each element. So you can get all information about the feature, how it's created, like extrude, revolve, sweep, all of those features. But in BVLit Inventor plugin, it's just a solid. It's just a block. You haven't the ability to make any change or know how it's created. The second point is the sheet metal items. In SEG software, all sheet plates will be created from sheet metal items. So you have the ability to get the sheet metal flat pattern, but in BVLit Inventor plugin, it's not an option because it's a solid. It's just a block as we discussed in the first part. The third point is customization of elements. In SEG, you have the ability to make a customization, and we will discuss this point in detail when we import or in our demo. But in BVLit Inventor plugin, you haven't the ability to make a customization in your elements. The fourth point, which is changes from revision to another revision. Let's say your client makes some changes, like changes the size of the nozzle, changes the rating of the nozzle, changes the location, orientation, all of that. By using SEG, you can make those modifications easily. But in BVLit Inventor plugin, it's not an option. You will need to generate the 3D model again and start your process from the beginning and create your drawings from scratch again. Fifth point, which is the ability to add more attachments. By using SEG software, you have the ability to add more attachments to your equipment, like nameplates, lifting lugs, platform supports, a lot of attachments. But in BVLit plugin, you have the ability to do that. Even you will make it manually. So you will draw your parts and make your assembly and assemble it manually. The drawing automation. By using SEG, you have the ability to make automation for your drawings. You can have the ability to export tables to your drawing and arrange your drawing automatically. But in BVLit Inventor plugin, it's not an option. The last point, what's happened if you haven't a BVLit file? In SEG, if you haven't a BVLit file, you have the ability to create your model from scratch. You have the ability to add your items like head, shell, nozzles, support saddles, skirts, all of that. You have the ability to add it because you have a library. But in BVLit Inventor plugin, if you haven't an Inventor file, you haven't the ability to create the 3D model. Here in our demo, we will make this vessel, inshallah, by using SEG. And from here, you can export the Access database file from the BVLit by click on the Access database button to export the Access database. Okay, now let's start our model. That's SEG, and from here we will click New, and let's generate a new project, BV demo, and let's select the location of the project, and we will select the overall from here. Okay, you can make horizontal vessel, vertical, heat exchanger, duct, tanks, and piping. Let's select overall. Okay, and from here we will make a rename for this vessel. Okay, now we will select this vessel, and from setting, we will open the equipment setting. And the equipment setting, you can change the position of the vessel and the direction of the assembly, but we will leave this point for the access file. And from here, you can change the delivered blade dimensions, because those dimensions shall be used, as we discussed before, for the shell blades. You can change your units and define the service of the equipment and serial number. Let's click Save. And from app setting, we will make all elements appear during creation. And from here, you can change the zooming option. And if you wanted to make your units in fraction, and select the fraction value. If you wanted to make it in decimal, a lot of options here, like the nozzle, if you want to make it appear on DIN or NBS, and the sorting number, and click Save. Now we will import the access file. So from import, here we will select import access file, and your file should be in millimeter, and all nozzles should be in NC imperial. Now we will import the access file. So from here, we will select the access database file and click import. Now SEG detects that this vessel is a horizontal vessel. So we will click save. And from here, it's automatically detect that the length of the shell in the access file is larger than 3 meters. So SEG divides them to 2 plates, and you can make a modification for the longitudinal welding line orientation. Here, let's make it 60 and click save. And from here, we will select the saddle shape. Here you have different shapes or configuration of saddles, so you can select the suitable shape and click save. Now, you can figure that automatically the tree is generated automatically. If we click on this node, for example, you can figure that we have an ellipsoidal head, and those are the dimensions that we get from the access file. Let's select the last head and flip the direction of head to make the convex to outside, not the inside. And we will select the vessel from here. And from here, we will save all information that we get it from the access file. This step takes seconds or minutes. It depends on the number of nodes on the tree. So after clicking on saving the tree, and as we said, this step save all data which imported from the access file. Now we will click on the assembly, and we will click on start button to start sending the information to the CAD software, which is in this case Autodesk Inventor. For example, here we will start making an elliptical head with those data. So if we come back to the Inventor right here, you can figure that this head is generated now on Autodesk Inventor. And now the other element, which is the nozzle. So we will generate the second nozzle with those information. After this nozzle, we will generate the flange and other. So during this, we will discuss a point regarding to the customization of your elements. Here, for example, after importing the data and the creation of the vessel, we will have a saddle. And this saddle, we need to make a customization on the configuration of this saddle to suit our fabrication requirements and our client specs. So you can figure here, we have 4 main shapes of the saddle. It will cover all of your requirements. For each one of those, you have many different cases. By using this mix, you can generate any shape you want. For example, for the first vessel, the web shape is straight, and you can make it narrow or straight at the bottom, or make it narrow or wide from the bottom. You can make the web to the right side, or the mid side, or the left side. The second shape, the web with straight edge, and this straight edge is going to the center of the vessel. So you can make the web at the bottom with a straight side, or narrow or wide like this, and the web itself, you can make it on the right side, or left side, or in the middle. The third shape, the straight edges of the web is coming down to the bottom, and the same, you can make the same options for the web bottom. The last shape, which is the saddle with lifting legs, you can make it, and the same option for the web width at the bottom. More options on the saddle, like you can make a cut on the web. In this case, in some specifications, you need to make a cut on the web to suit the anchor bolt tightening. You can make a slot holes. You can make the saddle without holes. You can make all hole pattern in 2 sides only, not with the longitudinal dimension. You can add up to 9 ribs to your saddle. So let's come back to the model here. and the 3D model of the equipment still generated here. Okay, and here, and still generated. Let's go back to another customization like lifting lug. In SEG software, we have 9 types of lifting lugs. In each one of those, you have many options. So you can, by those types, you can cover around 95% from cases in lifting lugs. We have different types of trunnions. For the first type of lifting lug, in this case, you can make this type of lifting lug for longitudinal direction, like below here, and you can control the location of the hole from the edge. So you can control dimension E to move the hole and make the offset of this hole. That shape for the circumference direction, so it is different from the first one. The first one is the longitudinal direction, and you have the same option for the dimension E. This shape is a common shape for lifting lugs, so you can use this shape. The fourth shape for this lifting lug is actually used for larger vessels and large weights. One of the most common shapes for lifting lug for vertical vessels. In this type of lifting lug, you have many different options, like make the lifting lug at the top with a fillet or with a chamfer, and from the bottom you can make it with a cut or without, or make this cut with a fillet. In each type of those lifting lugs, you have the ability to add a weir plate, you have the ability to add a cooler or not, so it's an optional, just a checkbox, you will select it to generate it. Okay, those types, and that's one of the most common lifting lug shapes. The last one of lifting lug, which is the cross direction. This actually used for large pressure vessels, and the lifting point is single lifting point. So this type is really common in larger vessels. Regarding to the trunnions, the options of the trunnion gives you flexibility to change the trunnion shape. You can make it from pipe, from plate. The inside ring, you can make one ring, 2 rings, or without any inside ring. The same for the external rings. You can make 1 ring, 2 rings, or without any external rings. The same for the end plate. You can make trunnion with it. So the mix of all of those options give you a lot of cases you can make it and cover your requirements. This type of lifting lug, with you can make it from pipe or plate, and you can control the orientation of the lifting lug. This is actually used in horizontal and vertical vessels. Okay, let's come back to our model. Now we have the 3D model of the equipment is done. Okay, and now we will make some customization to the saddle, okay, to suit our fabrication requirements. And we will make 2 different options on the 2 saddles. Let's select the left saddle, and from here we will remove the straight sides and change the width of the bottom of the web, and change the width of the base plate. And from here we will make a web cut and change the hole offset from the short edge and the long edge, and we will make this hole as a slide hole and change the slot length. Okay, and from here we will select the second row to make holes in 2 rows and click save. Now let's click start and go back to the end. Now if we take a look to the side view from here, you can figure that the web become narrow from bottom, the same for outside ribs, and the holes in base plate shall be slotted holes, and the web will cut. Okay, so you can change the configuration of the support saddle. Let's go to the next saddle, and from here we will remove this checkbox and change the bottom width. Okay, and from here we will change the hole offset from the edges and make a second row, and from here we will make the whole pattern on the short edge, not along the saddle. Okay, and let's click save and click start. we take a look from the front view, you can figure that the bottom width of the web is changed and become wide. Okay, after finishing the updating of the 3D model, we will come back to the general assembly of the vessel, and you can figure that the holing pattern, we make it all on the edges of the short side. Now we will add some attachments to this vessel, like lifting lug to the shell plates. Let's come back here and select the shell, and from elements we will select lug 1, and from here we will define the dimensions of this one. Okay. Now you have the ability to add a cooler. So if you wanted to add a cooler, just select this checkbox and define the cooler dimension. The same for wear plate. We will select it to add a wear plate and the location. And let's click save. Now we will click start assembly to send this element to the CAD software. Here, the assembly of the lifting lug, the cooler, and wear plate. Now we will add another lifting lug, and we want to make it the same like this one, but we don't want it to repeat the same dimensions again by hand. So from here, we will select the shell and select lug 2. But in this case, we will select make it same as lifting lug 1. So we will select this checkbox, and from here we will select. So if you select this node from the tree, you can figure that all dimensions become the same from lifting lug 1. The only thing we will do, which is that change the location of the second lifting lug. And now we will click save and click start. Let's come back to the inventor. After finishing the assembly of the lifting lug, it will be automatically assembled with the general assembly of the vessel. Okay, we will take a look to the bill of material of the equipment. You can figure that easily. The bill of material is generated automatically for each element and calculate the required items from each element, the material and the weight for each element. So now we have 27 elements right now, and let's add a nameplate for this vessel. So we select shell, and from here we will add external attachments like nameplate. So we add nameplate, select this one, and you have many different types. Let's select vertical type here and define the length and width height, the projection, and let's add as my nameplate the height. Let's add a client nameplate. Let's click save, and from here let's add a location. Let's make it 1200 on the 90-degree orientation, and let's click start the assembly. Okay, that's the bracket. After that, the ASME nameplate will take the right location, and the same for client nameplate. Okay, let's come back to the model here, and let's add a vortex breaker. Let's go back to the 3D model. We need to add a vortex breaker to this nozzle on the dome, head. So let's come back to the tree and select the bottom head from here, and from elements, you can figure that we have many different attachments. We will select vortex breaker and click add, and from the vortex breaker, you can make or change the dimensions of this plate, the offset from the center line, the width, the height, the inside diameter. If you wanted to add a perpendicular plate, you can add it from here. If you wanted to add a cover plate, you can add it from here and define the thickness of this one. And let's click save. And from here, we will click assembly to start the assembly of the vortex breaker. That's the first element. The perpendicular plate will be assembled. After that, the cover plate to the vortex breaker. After that, it will be assembled to the final model of the bezel. So let's take a section here. So from view, let's take a section. Here, we have the vortex breaker on this nozzle. Now let's add some attachments to this man wave. Okay, let's add a davit, hand grip, and stud bolts. We will come here, and from the tree we'll select the blind, and from elements we will add a davit. Okay, and from davits you will find many types of davits. You will select the required time and define the orientation and opening direction and click save. And from here we will add hand grip. Okay, and from here you have the ability to change the dimensions of this hand grip. Define the required number of the hand grip. We have 2 hand grips, and define the orientation. Click save. The last thing, we will add a stud bolt in 01 stud and click save. Now we will define the stud dimensions and click save. Now we will start the assembly. The first element in the tree we need to create it. It's the davit. So the information of this standard davit will be send it to inventor and create. And you can imagine that an engineer instead of you make this in your machine, because SEG deals with the CAD software and make it open a new part and select a plane, create a sketch, and make the feature like extrude or revolve or sweep instead of you. And you can imagine how much time you will consume if you make it by hand. But here, SEG make all of that instead of you. You just click a button and select the elements that you wanted to create. After that, send it to the CAD software, and after that, you will have the ability to see your model in 3D without spending more time. So you can save a lot of time, a lot of money in case of using SEG software. Now, we create the 3D model of this bezel, and now we will start creating the drawing. So we will select the bezel, and from here we will select drawing, and from create drawing, from this dialog box we will select the size of the drawing, and let's select it as A1. And from here we will make 2 views. Okay, and let's add another view. Okay, and the spacing between views. And from here we will make the elevation view to be a left view. And from here we will change define the location of the first view, define the scale of the bezel on the drawing, and from here we will select the required table that we need to export it to the drawing, like bill of material, design data, flange table, the nozzle table. If you have a fitting or gasket or something like that, and you wanted to export the drawing to the drawing, just select the checkbox. From here, the notes, you have some standard notes. You have the ability to edit it if you want, or delete it. You have the ability to add another notes. For example, if you wanted to add something like that, just you have the ability. If you wanted to edit or delete, just select the row and delete. From here, you have a rich library of standard welding details. You will just select the required welding detail from this form. After that, you will click save. From here, you have the ability to add a client document list, like the mechanical data sheet, thermal data sheet, any other documents from your client, and if you wanted to add it to your drawing, the visual document like your mechanical calculation, your thermal calculation, other detailed drawings and general arrangement, you can add it from here. The last thing, we will define the drawing name. It's a general arrangement, and it's IDW 001, for example. And from here, we will define that's the very revision. So we will make it revision 0. It's issued for review, done by A, checked by B, approved by C. Here, let's delete this, and let's add another empty rows like this if you wanted to add, and let's click save. And from create drawing, let's create the general arrangement drawing for this vessel. You can figure that the size of the drawing is changing automatically. The revision table updated and takes the right place on the drawing automatically. The bill of material the same, design data, the notes, and the nozzle table, all of that in seconds. Flange table, the client document list table, vessel document list. After that, the building details shall be imported to the drawing automatically. Those are the standard building details that you are selecting from the drawing. Now we will make the annotations and dimensions for our model. So let's make the tan line for this head, the same for this one, the same for that, and here. Add some center lines. Okay. Add some center lines for those nozzles, the lifting legs, and the manway. Now we will add the reference point, which we will measure from it. So we will use this point as a reference point, and now let's add the location for nozzles, and let's click continue. Now we have those locations, and let's add the same for this nozzle right here, and let's move this one a little bit down. Let's hide this origin point, and let's add the lenses or plates. The same for here, for the external projection, and the same for this nozzle, and the projection for this one, for example. Here, let's make this as a straight flange. Let's add the inside diameter, the thickness. Let's make it straight flange. And we will copy those properties to that one and that one. And for this one, we will make it thickness. And that one is ideal. Okay, let's add the 10 to 10 lens. Okay, now let's add some nozzle tags. So let's select this nozzle, and from here we'll select parts only. And now you can get the nozzle tag automatically. The same for this one, and the same for the other nozzles. If you wanted to add a lifting leg, for example, just select it, and from here select like this. Okay. Now we wanted to add a definition for each element, like the part number in the bill of material. At this step, we need to update the item number. So we will go back to the model, and from the assembly tab, we will select update item. By clicking on this button, we open the bill of material here. Sorry, if we open the bill of material here, you can figure that each identical elements shall be accumulated with each other. Like for item number 17, for example, is a cooler. So SEG detected that there are 4 items are identical. So this number, which is 17, will be sent or will be updated to each element in inventory. So to reflect that on your drawing, you should make the step of update item number before add the balloon or the item number on your drawing. Let's close this and let's come back here. It's still updated. It takes a minute or 2 minutes to be done. It depends on the number of elements inside your model. Now it's done. So if we come back and select the balloon, for example, and select the item number of the balloon and select this one. Okay, this item is item number 1. So if we come back here, item number 1 is an ellipsoidal head, and that's the definition of this head. We have 2 heads. So if we select the second head, for example, it's item number 1. We select this head, it's item number 2. If we check it on the bill of material, item number 2 is an ellipsoidal head, and that's the definition of this head. Now we will discuss another point regarding to the customization. Now for this nozzle, for example, we need to modify the projection of this nozzle. In SEG software, we will come back and select this nozzle, and from here we will select the calculator button and define the projection. We need to make this projection as 650. So let's come here and make it 650 and click 1 minute. It's measured here from the tan line, but here in this form, it's measured from the weld line, the seam line. Okay, so the value from the seam line will be 650. So if we click calculate on this button, it will be automatically calculate the required the calculated projection of the nozzle. We click save and click start the assembly. This nozzle projection will be changed. Okay, and if we come back to the drawing and check if this is changed or not, you can figure that the value is changed. We measured it to be 650 from the seam line. Okay, sorry, let's change the measure point from the facing, so it's 650 from the facing of the nozzle. The same we will do it with the manway. For example, we will measure from the facing of the manway to the center of the vessel, and we need to modify this to make it 1100. So we will come back to the manway nozzle, and from the calculator we will define this to be 1100. Just click calculate to calculate the projection of the nozzle and click save. One more options regarding to the welding, set welding detail. Here you can define the weld detail or the fillet weld for the nozzle from this dialog box, and you have the ability to define the nozzle surface from here. So for example, you can make it as a man way, and if we click save and come back to the tables and open the nozzle table, if we take a look to nozzle M01, now the surface of this nozzle is changing. During importing the information from the access file, you have the ability, or on the DVLit file itself, no surface for the nozzle, no place to enter the surface of the nozzle. And right here, the welding detail automatically calculated, and the values of the welding that you enter, the external projection of the nozzle is calculated automatically. Now let's make a detail for the saddle. Let's select this saddle and right click, and from here we will select drawing, select the drawing size, select the views that we need to create it, and from here we will select front view and make the location to be of the drawing like this, and the scale is 14, and from here we will add a bill of material only we will remove the building and nodes. And from here, we will add automated dimension to the drawing. So we will select dimensions and we'll select 2-point distance dimension. And from here, let's add a revision table, saddle detail, and IDW 002, for example, and let's click create. Here, you can figure that the views of the saddle are done with the dimensions, but you can figure that all dimensions are, a lot of dimensions are done and added to this view, and this make a conflict. So you can make delete not required dimensions like this, it's an option, or you can create your drawing without automated dimension. So it's repeat it without dimensions. So let's create drawing, let's delete the current drawing, and from annotations, let's remove the dimensions and let's start the drawing again without any dimensions. Here, we can make a section, for example, for the saddle, like this. And if we want to make a detail for the hauling, for example, like this, and make the scale to 5, and define the dimension of the slot hole, like this. Okay, the same for the others. And if you wanted to make automated center lines, just select this and click K2 and automated center lines. Now, after generating the 3D model for the support saddle and the general arrangement drawing of the vessel, and how we can get the automated bill of material and exporting it to the Excel format, the same for models, table, and a lot of tables, other tables, we will start a new project. And in this project, we will create a storage tank, small storage tank. So from here, we will add a new equipment. Let's add tank. Okay. And let's click add. And from here, we will set all of our model. Okay. And let's delete this equipment. And from here, we will select this equipment, and from the setting tab, we will define the position of the vessel. It's a storage tank, so it will be a vertical, and we will start the arrangement from the bottom to top direction. We will define the delivered blade dimensions. We will define the units, and let's click save from here. And for elements, let's add an annular plate. From the annular plate, we will define, we have many different types: annular plate with equal pieces, or annular plate with different pieces, so you have the ability to control the arc length for each one. Annular plates with different pieces and the thicknesses, so you can control each thickness of each plate. Now let's define the inside diameter of the annular plates, define the thickness of the first course, the annular plate thickness, the projection of the annular plate, the straight edge with dimension W, the bottom thickness, and the longitudinal building line orientation, and the number of segments. Now we will click save and start the assembly. Here, the assembly started, and the arrangement of the annular plates will start automatically. Now we will go to the next step, which is generating the bottom plate. So from here, we will select the tank, and we will go to the element tab. Okay, and from the element tab, we will select the arranged sloped bottom. You can make it flat bottom. We will make it as a slope. So we will create this bottom plate, and from here, select if it's sloped to inside or the outside like this. Define the bottom thickness, the overlap, and the bottom diameter of the of this plate. Okay, define the material, define the slope of this bottom, the cut torch length, and from here we will click Save and open the update log. From here, you can figure that we have some initial conditions, like if you wanted to add a mid-row, just select this one and row plates. So you will get this. If this arrangement does not suits your requirement, just make set grid and test it without that. In this case, you haven't a mid plate. If you wanted to make a change for example, make offset for this one, just define the offset value, for example, and make it like this. So you have the ability to change the initial conditions to start your modeling like this case and change the orientation. Let's make it at 0 and click Save. Now let's start the assembly. Now the blades of the bottom of the tank start assembled with all information like the overlap and the same arrangement that you selected from the module of blade arrangement. After finished, it will be assembled automatically to the annular plate. Now we will add some shell plates to this model. From the tank here, we will add shell, can 1, and from can 1, you can figure that we have many different types. We will select a shell from different pieces and thicknesses. In this type, you have the ability to define the length of each blade and the thickness of each blade in this shell course. We will define the inside diameter, the course height, the main thickness of the course, the gap of the build, the number of courses, and from here we will define the length of the first course and the start orientation angle, for example, and click Update. Okay, so we will define the thickness of each blade, 12, 12, and let's make this one at 16 and the last one at 12. Okay, for example, it's just an example. Now we will click Update Grid and Save. Now we will add another can. Sorry, let's add another can and 2. But in this case, we will not select different thicknesses. It's just from different pieces, but the same thicknesses. Define the inside diameter, the thickness of this shell course, the number of segments, define the length of first course, the first orientation angle of this course, click Update and click Save. Now we will add another shell course, can 3, and let's make it looks like can 2, but we will change only the thickness. So from here, we will select can 3, and we will change the thickness and start angle. Click Update and click Save. Let's add another course, can 4, and let's make it looks like can 3, and click Add. But we will change the thickness, make it 6 millimeters, and the start angle is 0 degree. Click Update and click Save. Now let's click Start to start creating the shell courses. Now the blade arrangement will start according to your selection, and you can figure that here in this one, the blade with a different thickness takes a different color to show you that this blade with a different thickness. You can use this option actually in clean outdoors. So because this is a piece fabricated separately, and after that it will be assembled with the storage tank. And the shell blade actually made from a different thickness because it's have a large opening for the clean outdoor. So you will replace this cut with a more thickness on the shell. Here that's the third can. It's assembled and will be added to the final model of the tank. the last shell course. After that, inshallah, we will add the compression ring and we add a roof and some attachments to this tank, like a clean outdoor and roof plate cover. I think we have 10 minutes remaining in this session. Now we will come back to the model, and from tank we will select compression ring. So we will select this one. We will add a compression ring, and from this compression ring you have the ability to select the shape of the compression ring. We will select the detail B according to the API and define the inside diameter of the compression ring. Select the size of the angle and click save. Now we will add a roof. So from elements we will add a ranged roof, and from here we will define the inside diameter, the slope, the thickness of the roof, the overlap, and the inside diameter of this one. Okay, the cut thickness of the roof, and from here let's change the scale, save, and create your updates. Let's make it with a mid row like this, and if you want to move this plate a little bit or make it offset, just select this one and let's define it to be offset with 2 millimeters, for example. So you have this shape, and if you wanted to rotate or split something like that, for example, if you wanted to split this one to right like this and make it this one as centered, for example, so you can make an option of this one. And if you wanted to make a set grid and rearrange your model again like this, so you have many different cases you can select between them. Let's reset grid and row plates like this with a mid row, and make this one with the offset and change the orientation. Let's make it 45 degrees and click save. Now we will click start assembly to start creating the compression ring. After that, the roof plate arrangement. The same for the bottom will be done on the roof. Each plate you created here, it will be created on the CAD software. Okay, so it's created here. Okay, after creation, it will be assembled to the final model. After that, we will add a clean outdoor to the shell plates and add a cover to the roof. Now, as we discussed here, you can figure that this plate with a different thickness, this one right here, and let's add a clean outdoor to this shell. So let's select this shell, and from here let's add clean outdoor. Okay, and from here select the shape of this one. Let's move this from here, and you can select the configuration of the David. So you can select between those types. Just select the required type, select the size, and select the orientation. Let's make it 45 degrees, for example, and click save. Define the set value. Click save, and now let's click start assembly to start creating the runway or the clean outdoor. Here, that's the neck plate. Okay, after that, the rebad flange. The flange is fabricated from two pieces, one around the neck and the other at the bottom. After that, the gasket and the cover plate. So you can figure that the assembly of each element done automatically instead of you. So you can imagine how much time you will save. Here the stud bolts or the bolts. the nuts. And finally, the davit. After finishing, it will be add to the final assembly. And anytime you want to make a change or something like that, you have the ability to do it easily by using SEG software. If you want to change the size, for example, change the type, just go back to the node and change your information here and send it back to inventory. Let's add an anchor chair from here. And from this dialog box, let's add a wheel plate and keep those dimensions and make them 8 pieces, and change the orientation of the first one. Let's make it on 5 degrees, for example, and click Save. Now let's click Start. So the anchor chair will be generated and assembled automatically. After that, it will be add to the model and the pattern. Okay, a circular pattern for this one around the tank. And easily you can detect if you have any flash or something like that. So you can decide if you wanted to rotate or change the orientation, change the number of the anchor bolts around the tank or not. I think now we cover all of points in this session. And if you have any questions, you can go ahead. Hello, Fawzan? Hello? Fawzan, can you hear me?
Yeah, hi, Mr. Ahmed.
Yes.
Yeah, Deepak this side.
Hello?
Yeah, hello. Can you hear me?
Yes, but the voice is a little bit not clear.
Someone, can you speak?
So any questions in this session after making a complete model from BV Elite? After that, make a customization on these saddles, add another attachments like Vortex Breaker, lifting lugs, davit, grip, bolts to the manway, adding nameplate. After that, we make a general arrangement drawing for the whole vessel, with including many tables like bill of material table, notes, design data, nozzle table, flange table. After that, we make a detailed drawing for the saddle with automated dimension if you would like. And if you would like to add dimensions by hand, you can make it. After that, we make a storage tank, small storage tank, including annular plates, bottom plates, roof plates, chill blades, arrangement, anchor, chair, and clean outdoor. So any questions regarding to the above points?
We have several questions. Okay.
Okay.
But what I am thinking is that can we answer all these questions offline? It means after the meetings, because we are going with a go-to meeting. So after the webinar, okay, we will consolidate all these questions and we can reply positively.
Okay, inshallah. I will wait all of your questions and you will get a reply soon, inshallah.
Yes. Yeah, we will arrange the questions and we can reply one by one to all the participants.
Inshallah.
Yeah. Yeah. Thank you. Thank you very much, Mr. Ahmed. So
thank
I think we can close this session now.
And I hope this session or this webinar cover your imagination about this software. Actually, this software is amazing. It's a unique software. No existing software can do all of that under one umbrella. You can make pressure vessels, towers, heat exchangers, and storage tanks, slug catchers, launchers and the receivers, all of that under 1 and 12. No existing software in the world can do that.
So we can
Okay,
close this. Yes, so we can close this session now. And what are the questions are there? We'll go and we can reply one by one to all the participants.
Okay, thank you for your time and waiting for your questions, inshallah.
Yeah, you can close from your side. Yes, you can close from your side, sir.